So if we move into 7.4, we've got arc length. We can find the arc length of a curve. Like if you laid a tape measure on here and measured this curve. And it's this kind of crazy formula. The square root, the integral of the square root of 1 plus the derivative squared. Wow. And when you do these problems, then what happens is this is a nasty integral. It's hard to do. And so there, I mean, usually, depends on the function, maybe, depends on what function you got, but usually, when you take the derivative of the function and square it and add 1 to it and put it in a square root and try to integrate it, you're in an unintegrable situation. You can't integrate it, maybe. Again, we're in this class where, first of all, you can't integrate everything. There's a lot of stuff you can't integrate by hand. We're going to learn more techniques later in this class how to integrate stuff. But even then, there's still stuff you can't integrate. And here's a kind of a classic example. So we may want to use the aid of technology to help us do some of these integrals. So let's just try something here. If I said, please find the arc length of this parabola from, this is a parabola, it's y equals x squared, very basic parabola. It doesn't look too good, I didn't do a great job there. And let's say I want it from 0 to 1, 2, 3, to 3. By the way, when it hits 3, the y value is 9. But I guess I want this much. I want this arc length. Okay, well, there's your formula. Oh, by the way, I want you to know how to do area in 7.1 and how to do the volume in the disk method, with the disk method and with the shell method. And I kind of want you to know those formulas. Memorize them and be able to use them. This one, I think I'll give you. If I give you a question, I'll kind of give you this formula in the question. I'll say, hey, remember arc length is this formula? And I'll just give you this one. You don't have to memorize this one. So here I go. You don't have to memorize the formula, but you got to try using it. Here we go. I want to just do this. I guess it's kind of easy, right? Set up the integral. I guess it would be the integral. I would have a square root, and I would have 1 plus the derivative squared. What is the derivative?
2x.
Oh yeah, 2x. So it's the derivative 2x, the entire thing squared. So, by the way, that's a 4x squared, I guess. And I guess I'm integrating from where to where. These are in x's.
0 to 3.
So 0 to 3 would give me this length, this arc length. Yeah. I mean, the other thing I've done previously in this class is when I give you these formulas, I've sort of explained them to you. Okay, so I didn't do that today, did I? I just said, hey, if you want arc length, here's your formula. Shut up and do it. I mean, I didn't explain where this came from. I didn't derive it for you. Maybe we could talk about that, but anyway, here I am, and like I sort of previewed. I mean, I tried to come up with an easy function, and guess what? You can't do this. You cannot do this. You just, I mean, and again, depending on your abilities and skills of integration, you either recognize that you can't do this or you think you can do it, but I'm just telling you, you can't. U substitution won't work. You know, if there was an X out front, maybe you know how U substitution works. If there was an X out front, you could deal with it then. You could do U substitution. It'd be the du would kill that X out front, but we don't have that. So U substitution doesn't work. Again, up in chapter 8, we'll learn a technique called trig substitution, and then we will be able to do a problem like this. But today we can't. So what do you do if you can't do it?
You cry.
Well, so you,
You're done.
technically, okay, so I'm saying you can't do it by hand, or what that means is you can't do it analytically.
Yeah.
So you know what you could do? You could do it numerically. You could add up a bunch of rectangles. Anybody want to add up a bunch of rectangles? A couple hundred rectangles? No, but you, and okay, so if you don't want to add up a couple hundred rectangles, maybe you could ask a computer to do that. That's something like a computer loves to add up rectangles, you know? But then you need a little program of some type, but it would be glad to add up 200 rectangles or 100 rectangles or 8 rectangles or whatever. It would add up. But so a computer could numerically estimate this, you know, or a calculator. Maybe I'll show you something.